Hello children, today I am here to teach you chapter 11 in your textbook, that's factors and multiples. So in this lesson we are finding factors and multiples of a whole number and we are trying to solve problems related to factors and multiples and examine whether a whole number is divisible by 2, 5 and 10. Look at this one, multiples of 2. You already know multiples of 2. So, what are the multiples of 2? 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times 4, 8. 2 times 5, 10. 2 times 6, 12. 2 times 7, 14. 2 times 8, 16. 2 times 9, 18. 2 times 10, 20. Write down the last digit of the multiples of 2. So when you look at the last digit, I see 0. What else? 2. Then 4, 6, 8. These are the last digit of the multiples of 2. These are even numbers. If the last digit is an even number or 0, the number is divisible by 2 without a remainder because these are multiples of 2. So look at the last digit. If the last digit is 0 or even number, the number is divisible by 2 without a remainder. Multiples of 5. 5 times 1, 5. 5 times 2, 10. 5 times 3, 15. 5 times 4, 20. 5 times 5, 25. 5 times 6, 30. 5 times 7, 35. 5 times 8, 40. 5 times 9, 45. And 5 times 10, 50. Now write down the last digit of the multiples of 5. When you look at the last digit, you can see either 0 or 5. So if the last digit is 0 or 5, the number is divisible by 5 without a remainder. So how we identify whether a number is divisible by 5? Look at the last digit. If the last digit is 0 or 5, the number is divisible by 5 without a remainder. Multiples of 10. 10 times 1, 10. 10 times 2, 20. 10 times 3, 30. 10 times 4, 40. 10 times 5, 50. 10 times 6, 60. 10 times 7, 70. 10 times 8, 80. 10 times 9, 90. And 10 times 10, 100. Look at the last digit. All are zeros. So how we find out whether a number is divisible by 10? Look at the last digit. If the last digit is 0, the number is divisible by 10 without a remainder. Now underline the numbers that are divisible by 2 without a remainder. So how we identify? Look at the last digit. The last digit is 0 or even number, the number is divisible by 2. So here, this is 4. It's divisible by 2 without a remainder. But this is odd number. This is again even. It's divisible. Here 0, it's possible. And 7 is an odd number. It's not divisible. 9 also odd number. 4 again, yes, it is an even number. And 672, the last digit is an even number. Underline the numbers that are divisible by 5 without a remainder. So if the last digit is 0 or 5, it is divisible. So this one, this one, here this one, here. These are the numbers that are divisible by 5 without a remainder. 5 or 0 as the last digit. Underline the numbers that are divisible by 10 without a remainder. So that means the last digit should be 0. So 240, this number, here possible, this is possible, and you can't take the other two. Underline the 3-digit numbers that are divisible by 2, 5 and 10 without a remainder. So what's the condition? This should be an even number if it's divisible by 2. 5 means either 0 or 5. But 10 only 0. That means if we want to find out a number that's divisible by 2, 5, 10, the last digit should be 0. So we'll find out what are the numbers with last digit 0. This is divisible. This is divisible. Here it's divisible. These are okay, but other numbers you can't take. Give the reason that 360 is divisible by 2, 5 and 10 without a remainder. As 360 is an even number, it is divisible by 2. As last digit is 0, it is divisible by 5 or 10. Look at this one, 10, 20, 30, 40, 50. Those are multiples of 10. As last digit is 0. Is it divisible by 2? Yes, because the last digit is 0. It's divisible by 2. So we say yes. Is it divisible by 5? Yes, last digit is 0. 0 or 5, it is divisible by 5. Is it divisible by 10? Yes, because the last digit is 0. Write down 10 multiples of 3. So starting from 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. So 3 times 6, 18, 3 times 7, 21, 24. So how many we need? Another 3. 24, 3 times. So this is 3 times 8, 3 times 9, 27. 3 times 9, 27. And 3 times 10, 30. So altogether 10. Now write down 10 multiples of 4 times table. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24. 4 times 7, 28. 4 times 8, 32. 4 times 9, 36, and 4 times 10, 40. Write down the common multiples of 3 and 4. Look at carefully what are the common numbers. So I'll highlight those. Common terms. Can you see? 12. Then what are the other numbers? 24. Then, according to this one, that's all. Write down the lowest common multiple. Out of these common multiples, what is the lowest one? That's 12. Look at this one. Write down 12 multiples of 4. So we'll write it again. 4 times 1, 4 times 2. 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, 4 times 9, 4 times 9, and 4 times 10, 4 times 11, and 4 times 12. So we need 12 multiples. Write down 10 multiples of 6. 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5, 6 times 6, 6 times 7, 6 times 8, 6 times 9, and 6 times 10, 60. So we need 10 multiples of 6. Write down the common multiples of 4 and 6. By looking at these factors, you can write down common one. What are the common ones? I can see 12. Then, what's the next one? 24. Next one, 36. And you get 48. Now, write down the lowest common multiple out of these. The lowest one is 12. Now, what are factors? Can we divide 18 mangoes between 2, 3, 4, 5, 6 friends without a remainder? So, we'll figure out 18. When you divide by 2, you get 9. So, it's a whole number, so you can divide. Then, divide by 3. So, we'll divide by 3 now. 18 divided by 3. So, you get 6. 18 divided by 4. Can you divide? 4 times 4, 16. And there's a remainder. Remainder 2. 18 divided by 5. You get 5 times 3, 15. Remainder 3. 18 divided by 6, you get 6 times 3. So, can we divide 18 mangoes between 2? Yes. 3? Yes. But you can't divide it by 4. Can we divide it by 5? No. But we can divide it by 6. Numbers that are divisible without a remainder, that's 2, 3, and 6. Numbers that are not divisible without a remainder, that's 4 and 5. If a number divisible by another number without a remainder, then the second number is a factor of the first number. So here we can say 2 is a factor and 9 is also a factor. 3 is a factor, 6 also a factor. 6 is a factor and 3 also a factor. Now we found out 18. You can divide by 1, that's 80. Divide by 2, that's 9. Divide by 3, that's 6. Divide by 6, you get 3. Divide by 9, you get 2. 18 divided by 18 also possible, you get 1. All are whole numbers without a remainder. So those are called factors of 18. So what are the factors? Starting from 1, then you get 2. It's divisible by 3, divisible by what else? 6, 9, and then 18. So we call these are factors of 18. Look at carefully. You see 1 and the number itself also a factor. Look at this number 12. We'll find out what are the factors. We know 12 we can write 1 times 12. If we take 2, 2 times 6, 3 times 4. So 12 can be written as multiplication of 2 numbers. All the whole numbers are called factors of 12. So all these numbers we call factors. So what's the lowest one? 1. Then 2, 3, 4, and what else? 6 and 12. Those are factors of 12. Write down the set of factors of 36. So 36 I can write 1 times 36. 36 is again 2 times what? You can divide by 2. You get 2 times 18. 3 times, divide by 3, you get 12. 4 times 9, 36, and 6 times 6. Now what are the factors? So you have to write all. 1, 2, 3, 4. What else? Now 6 twice is there, but we don't write 6 twice in the set, only once. So we can write 6 only once, and then 9, 12, 18, and 36. So those are the factors of 36. Write down the set of factors of the following numbers. Factors of 1. 1 is 1 times 1. So just 1. Factors of 2. 1 times 2 or 2 times 1. So 1 and 2. Factors of 3. 1 times 3. 3 times 1. Factors of 4. 1, 2 times 2, and 4 times 1. So 1, 2, 4. Factors of 5. 1 times 5. And what about factors of 6? 1, 2 times 3. So 3 is there, and 6 times 1. Factors of 7. 1 times 7. 1 and 7. Factors of 8. 1, 2 times 4. So 2, 4. And then 8 times 1. Factors of 9. What are the factors of 9? 1. 3 times 3. We only write once, and 9 times 1. Factors of 10. We can write 1. Then 5 times 2. So 2 times 5 and 10. Factors of 11. 1 times 11. So 1 and 11. And factors of 12. 1 times 12. 2 times 6. 3 times 4. And here 2 times 6 and 12 times 1. So these are the factors of all these numbers. Now when you look at carefully, always 1 and the number itself are the factors of any number. So look at carefully, 11 is there, 12 is there, 10. So 1 and the number itself is always a factor. So what are the factors of 12? So if you can't figure out, you can divide also. 2 times 6, 2 times 3, 3 times 1. So what are the possible factors? 1. 2 times 6. 3 times 4. So 4 is also there. Then 6 times 2. And then 12 times 1. Factors of 12. Factors of 18. When you divide by 2, you get 9. So 1, 2. When you divide by 3, you get 3 times 6. Then 3 times 6. Then 6 also possible. 2 times 9. So 9 is also possible. And 18 times 1. 18. So these are the factors of 18. Some numbers have factors 1 and the number itself only. Look at these numbers 2. Only 1 and 2. 3 is 1 and 3. 5 is 1 and 5. 7, 1 and 7. And 11, only 1 and 11. 13, also 1 and 13. 17, 1 and 17. 19, 1 and 19. 23, 1 and 23. 29, 1 and 29. So these numbers we call as prime numbers. So what are prime numbers? The factors are only 1 and itself. Only 2 factors are there. What is the number that only has factors of 1 and 31? That's only 31 because 31 is a prime number. What is the number that only has factors of 1 and 73? 73 is a prime number. That's 73. Now we'll look at how we can solve problems using factors and multiples. Price of a pen is 16 rupees. Find the price of 7 such pens. So what we do? We take the multiples of 7. Multiples of 16. So price of 7 pence. 16 times 7. So 7 times 6, 42. 4 remaining. And 7 times 1, 7 plus 4, 11. So 112 rupees. So what's this answer? That's the 7th multiple of 16. So 16, 32 like that. You take the 7th multiple of 16. Fill in the blanks. 1 kilo price is given for sugar. What about the price for 3 kilos? You multiply. 115 multiplied by 3. 3 times 5, 15. 1 remaining. So 3 times 1, 3. 3 plus 1, 4. 3 times 1, 3. 345 rupees. 1 kilo of flour is 70 rupees. What about 4 kilos? You multiply. 4 times 0, 0. 4 times 7, 28. 280 rupees. Now what about dal? 1 kilo is 150. We need 2.5 kilos. So we can do separately. If it's 150 for 1 kilo, what about half a kilo? We divide by 2. 150 divided by 2, you get 75. And 2 kilos means you multiply by 2. 150 times 2, you get 300. So 300 plus 75, you get 375. 1 kilo of rice is 80 rupees. And what about 3 kilos? Multiply by 3. 3 times 0, 0. 3 times 8, 24. What about this one? 1 salmon tin is 150. What about 3? So 3 times 150. 0. 3 times 5, 15. And 3 times 1, 3 plus 1, 4. 450 rupees. Now, how we find out the total? Just add all these together. 5 plus 5, 10. 1 remaining. 5 plus 8, 13. 13 plus 7, 20. 25 and 29. 2 remaining. 5 plus 2, 7. 7 plus 3, 10. 10 plus 4, 14. 14 plus 2, 16. So 1,690 rupees is the total cost. Now this table shows 10 by 10 multiplication. 10 by 10. Using the table, we can write the factors of 12. Can you see? 3 times 8. 3 times 8. 24 again. 4 times 6. And 24 again, 6 times 4. And 8 times 3. So it shows some factors of 24. So what are the factors? We can write all these numbers. So it's 1 times that one, not given here. The table only shows 10 by 10. So up to 10. So factors of 24, by looking at this table, we can see 3, 4, 6, 8, 3, 4, 6, 8. Those are the factors. We can get it from this table. Using the previous table, show that the ways you get 18. So we'll look at 18 and see where you get 18. Here. 9 and 2. What else? 18 is here. 18 is here and here. That's all. So 2 times 9. 2 times 9. Then 3 times 6. 6 times 3 and 9 times 2. 6 times 3, 9 times 2. So what are the factors of 18 using that table? We get 2, 3, 6, 9, 2, 3, 6, 9. That's all we can see from that table. Now we'll look at the exercises and example in your textbook. Example 1. Find the factors of 20. How we find out the factors of 20? So 20 I can write 1 times 20. Then divide by 2. 2 times 10. Then can we divide by 3? 4. 4 times 5. 5 times 4 is also same. 6, not possible. 7, not possible. 8, 9, 10. 10 times 2. So what are the factors of 20? We can write down 1, 2, what else? 4, 5, 10 and 20. So those are the factors of 20. And remember, 0 is not a factor of a whole number. Exercise 11.1. Fill in the blanks with the appropriate whole numbers. 4 I can write 1 times 4. What about 2 times 2? So 1, 2 and 4 are the factors of 4. Look at 7. 7 I can write 1 times 7. So what are the factors? 1 and 7. This one, 8 I can write 1 times 8. 2 times 4. So what are the factors? 1, 2, 4 and 8 are the factors of 8. 15. 1 times 15. And I can write 3 times 5. So what are the factors here? 1, 3, 5 and 15. 24, what are the factors? 1 times 24 and 2 times 12. 3 times 8, 4 times 6. So what are the factors? 1, 2, 3, 4, 6, 8, 12 and 24. When the factors of 18 are written, we obtain. What are the factors of 18? 1 times 18. 2 times 9. And 3 times 6. So 1, 2, 3, 6, 9, 18. When the factors of 40 are written, so 1 times 40. 2 times 20. Then 4 times 10. And 5 times 4 and 8 times 5. So we can write 8 also. Now look at question number 2. Find the factors of each of the following numbers. 5. 5 is a prime number. So what are the factors? 1 and 5. 5 times 1 only. 27. We can write 1. 1 times 27. So 27 is also a factor. So you can divide by 3. 3 times 9. So 1, 3, 9 and then 27. So you can divide and see. 27 divide by 3, you get 9. Divide by 3, you get 3 here. So 3 with 9 and 9 with 3 and 27. So those are the factors of 27. 17 is a prime number. So what are the factors of 17? 1 and the number itself, 17. 22. So 1 is a factor. 1 times 22. 2 times 11. So you get 1, 2, 11 and 22. 21. You can divide by 1. 1 times 21. 3 times 7. So that's all. And 31. 31 is a prime number. So 1 and the number itself, 31. 32. 1 times 32. 2 times 16. 4 times 8. Then 2 times you get 16 and then 1 times 32. 45. You get 1. This is divisible by 3. 3 times 15. Then 5 times 9. 45. So 3 times 15 and then 1 times 45. So those are the factors of 45. 50. So what are the factors? Divide by 1, you get 1 times 50. 2 times 25. 5 times 10. 10 times 5 and 2 times 25 and 1 times 50. 60. How can we find out factors? 1 is always a factor. 2 times 30. 3 times 20. 4 times also possible. 60 divide by 4. Get 4 times 1, 4. For 20, that's 5. So 50. Then 6. 5 also possible. 12 times 5. Then 6 times 10. Now we'll write down the other numbers. 5 times 12. So 6 times 10. 5 times 12. 4 times 15. And 3 times 20. What else? 3 times 20 and 2 times 30. And then 60. So those are the factors of 60. Now we'll look at example number 1. What are the factors of 72 that can be found using the above multiplication table? So we'll look at the table and see how we get 72. Where you get 72? One is here and another one is here. So 72 means 9 times 8 and 8 times 9. So I can write 72 is 9 times 8 or 8 times 9. So that means factors of 72. Factors of 72. I can take 8 and 9 from the table. Example number 2. What are the factors of 18 that can be found using the above multiplication table? 18. One is here. Another one is here. This one. What else? This one. So what are the possibilities? 2 times 9. Then 3 times 6. 6 times 3, same. And 9 times 2, same. So from this table, what are the factors of 18? I can write factors of 18. That's 2, 3, 6, 9. Exercise 11.2. What are the factors of each of the following numbers that can be found using the 10 by 10 multiplication table? So we have to refer this table. 48. Where you get 48? 1, 2. So 2 possibilities. So what are the factors? I can write 6, 8. That's all. 6 and 8. 81. Here, only one possibility. 9 times 9. So I can say 9 is a factor. 2. This one, this one. That's all. 2 into 1, 2 into 1. So 1 and 2. 28. This one. What else? Here. And that's all. So 28 means 4 and 7. 7 times 4. 4 and 7. 40. Here. And you get 40 here and here. So 10 times 4. And what else? 5 times 8. So 4, 5, 8, 40. So 4, 5, 8 and 10. So those are the factors of 40 from the table. Obtain different ways in which 36 can be written as a product of two whole numbers using the 10 times 10 tables and fill in the blanks. 36. So we need to find out what are the possibilities we can get 36. Check this one. 9 times 4. 6 times 6. 4 times 9. So 6 and 6, 4 and 9. So 9 and 4, 4 and 9, 6 and 6. Those are the three possibilities. Write down in ascending order the factors of 36 which can be obtained from the above products. So ascending means smallest to highest. So what's the smallest number? That's 4. The next number is 6 and 9. So those are the factors of 36. Obtain different ways in which 9 can be written as a product of two numbers using 10 by 10 multiplication table and fill in the blanks. 9. One possibility is there. So 9 times 1 or 1 times 9. What else? 9 is here. 3 times 3. So those are the possibilities. Another one, 1 times 9. 9 times 1. So these are the possibilities. So what are the factors? If you are asking to write down the factors, we can write 1, 3, 9. Write down the different ways in which 30 can be written as a product of two whole numbers using 10 by 10 multiplication table. Thereby write down factors of 30. 30. Where you get 30? Here and here. What else? So when you look at the table carefully, you get 3 ways. So 3 times 10. Or 5 times 6. Or 3 times 10. Or 10 times 3. That's the same thing. So what are the factors of 30? Factors of 30. 3, 5, 6 and 10. 3, 5, 6, 10. Is 4 a factor of 9? Explain the reason for your answer. So 9, what are the possibilities here? Here and here. So 9 you can write 3 times 3 and 1 times 9. 9 times 1 the same thing. So is 4 is there? 4 is not there. So 4 is not a factor because you can't divide, cannot divide by 4 without a remainder. So when you divide, you get a remainder. So that's not a factor. Example number 1. Find 3 factors of 30 by using the method of division. 30 you can divide by 1. You get 1 times 30. 30 divided by 2. 2 times 15. 30 divided by 3. 3 times 10. So they are asking only 3 factors. So you can write. Without writing 1 and the number itself, we'll take 2, 3, 10. So we need only 3. You can write 2, 3, 10 are factors of 30. Example number 2. Is 9 a factor of 12? Explain the reason for your answer. So we'll divide and see. 9 times 1. We'll do long division. 9 times 1, 9. And 3 is the remainder. You get a remainder there. So, is 9 a factor of 12? It's not. So, you can write 9 is not a factor of 12 because we get a remainder 3. Exercise 11.3. Find 3 factors of each of the following numbers using the method of division. 28 I can divide by 2. You get 14. Again, 28 I can divide by 4. 7. So, you need only 3 factors. So, I can write 2, 4, 7 and 14 also possible. So, I'll write 14 as well. 32. 32 I can divide by 2. You get 16. Again 32 I can divide by 8. 8 times 4. So what are the factors of 32? 2, 4, 8, 16. You can write. 54. 54 divided by 2. 2 times 2, 4. That's 7. Then 20 again. 54 divided by 6. 6 times 9, 54. So what are the factors of 54? I can write 2, 6, 9, 54, 27, 90. I can divide by 2. That's 45. And I can divide this by 3. 3 times 30. So what are the factors? 2, 3, 30, 45, 90. Those are factors. I'm only writing 3. 21 I can divide by 3. I get 7. What else? And 21 I can divide by 1. So 3, 1. So I can write 1, 3, 7, 21. Question number 2. Is 6 a factor of 84? We'll divide and see. 84 divided by 6. 6 times 1, 6. 2 remaining. For 24, that's 4. 6 times 4, 24. And the remainder is 0. So, explain the answer by the method of division. So, we can say 6 is a factor of 84 because the remainder, I'll write as remainder is 0. Is 5 a factor of 48? Explain the reason for your answer. So we'll divide and see. 48 divided by 5. 5 times 8. 40. 5 times 9. 5 times 9, 45. And 3 remaining. So the remainder is 3. We can write as remainder is 3. 5 is not a factor of 48. Example number 1. Check whether 14 is a multiple of 2 by dividing 14 by 2. 2 times 7, 14, and you get the remainder 0. So that means you can say, check whether 14 is a multiple of 2 by dividing. So 14 I can write 2 times 7. So that's a multiple. So you can write multiple of 2 by 7 is 14. Check whether 42 is a multiple of 3 by dividing 42 by 3. 3 times 1, 3. For 12, that's 14. That's 4. 3 times 4, 12. And the remainder is 0. So remainder is 0. So you can write 42 is 3 times 14. So that's the multiple. Exercise 11.4. Write down 5 multiples of 2 which are greater than 10. So what are the multiples? 2 times 5, 10. 2 times 6, that's 12. 2 times 7, 14. 2 times 8, 16. 2 times 9, 18. And 2 times 10, 20. So we need to write numbers greater than 10. Write down 4 multiples of 3 between 1 and 20. Multiples of 3. 3 times 1, 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. So 1, 2, 3, 4. Only 4 multiples. Write down all the multiples of 4 between 1 and 25. 4 times 1, 4. 4 times 2, 8. 4 times 3, 12. 4 times 4, 16. 4 times 5, 20. 4 times 6, 24. So those are the multiples of 4 in between 1 and 25. From the following numbers, select and write down the multiples of 3. So multiples of 3 means it should be divisible. 60. 3 times 20. Now we'll check 115. It's not divisible by 3. So we can show that 115 is not divisible. 3 times 3, 9. For 25, that's 8, 24, and the remainder is 1. So it's not divisible. 48, it's divisible. Just check. 3 times 1, 3. For 18, that's 6. So you can write 3 times 16. 26, you can't divide by 3. 14 also not divisible, but 27, we know that that's 3 times 9. So that's also a multiple of 3. How many multiples of 9 are there between 1 and 100? We'll check. 9. What else? 9 times 2. 9 times 3. 9 times 4. 9 times 5. 9 times 6. 9 times 7. 9 times 8. 9 times 9. 9 times 10. 9 times 11. Now, how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 multiples are there. Of these numbers, which is the greatest multiple of 9? What's the greatest one? That's 99. So, the greatest multiple is 99. Write down 3 multiples of 18. 18 times 1. 18. 18 times 2. 2 times 8. 16. 2 times 1. 2 plus 1. 36. Then multiply by 3. 3 times 8. 24. 2 remaining. 3 times 1. 3 plus 2. That's 5. 54. What is the largest multiple of 9, which is less than 150? So, we'll divide and see. 150 divide by 9 and see what's the number. 9 times 1, 9. So, you get 6. For 60, 9 times 6, 54. So, that's the remainder is 6. So, 9 times 16 is what? That's the largest number you can get. So, 16 times 9, you get 9 times 6, 54, 5 remaining. 9 times 1, 9 plus 5, 14. So, 144 is the largest possible value. Now, 9 times 6, 54. 9 times 1, 9 plus 5, 14. So, 144 is the largest multiple of 9. Write down 5 multiples of each of the following numbers. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5. So, we need 5 only. 13 times 1, 13 times 2, 13 times 3, 13 times 4. 4 times 3, 12, 4 times 1, 4 plus 1, 5. Then 5, 5 times 3, 15, 1 remaining. 5 times 1, 5 plus 1, 6. So, those are the 5. 15, 15 times 1, 15 times 2, 30, 15 times 3, 45. You can add 15 to that. 45 plus 15 or 4 times 15. That's 60. Then 6 times 15. 2, 3, 4, 5. We'll do 5 first. 5 times 5, 25. 2 remaining. 5 times 1, 5 plus 2, 7. So, 1, 2, 3, 4, 5. 18. 18 times 1, 18. 18 times 2, 36. 18 times 3. 3 times 8, 24. 3 times 1, 3. 3 plus 2, 5. 54. Then 4. 4 times 18, 32. 4 times 1, 4 plus 3, 7. 1, 2, 3, 4. We need another more. One more. 5 times 8, 40. 5 times 1, 5 plus 4, 9. So 90. 20. 20 times 1, 20 times 2, 20 times 3, 20 times 4, 20 times 5. So add 20 to each number. Question number 9, fill in the blanks. Any multiple of 10 is necessarily a multiple of 2 and 5. Because last digit is 0, that means divisible by 2. And 10 means it's divisible by 5 as well. 11 times 7 is 77. So therefore 77 is a multiple of 11 and of 7. 7 times 11 or 11 times 7. Write down two numbers which are multiples of both 3 and 4. 3 times 4, 12. 4 times 3, 12. Then multiples, any multiple is possible. So you can write 24. Write down a number which is a multiple of 2, 3, 4. So you can take 12 or 24. So 12 is divisible by 2. So that means 2 times 6. 3 times 4. 4 times 3. So you can write 12 or 24, any number. Example number 1. There are 30 apples in a bag. They are separated into bags such that each bag has an equal number of apples. Find out the number of apples in a bag and the number of bags in each instance. The total number of apples is obtained by product of the number of apples in the bag and the number of bags. Hence, we find out the number of bags and the number of apples in each bag by considering the products of two factors of 30. So 1 times 30. 2 times 15. 3 times 10 and 5 times 6. 6 times 5. 10 times 3, 15 times 2 and 30 times 1. So accordingly, there are 8 ways of grouping 30 apples in the bag containing the same number of apples. 1, 2, 3, 4, 5, 6, 7, 8. So bags with 1 apple in a bag and bags with 2 apples in a bag, bags with 3 apples in a bag and bags with 6, 10, 15, 30. So if there are bags with 1 apple, how many bags are there? So you get 30 bags. 2 apples in a bag, 2 times 15. You can make 15 bags. And 3 apples in a bag, you can make 10 bags out of that. And 5 times 6, so you get 6 bags. 6 times 5, so 5 bags. And 10 times 3, so 3 bags you can create with 3 apples in each. 50 apples in a bag, you can take 2 bags. And if there are 30 apples inside it only, you can get 1 bag. Exercise 11.5. The price of a ballpoint pen is 12 rupees. Find the price of 8 such pens. Is it a multiple of 8 and 12? So we'll check. So price of 1 pen is 12 rupees and price of 8 pens, 8 times 12. 8 times 2, 16 And 8 times 1, 8 plus 1, 9. So 96 rupees. So is it a multiple of 8 and 12? Yes, it's a multiple of 8 and 12. So 8 times 12 is 96 or 12 times 8 is 96. So yes, a multiple of 8 and 12. Question number 2. A water pump takes a day to fill a household tank of capacity 75 gallons. What is the number of times and the total volume of water it can fill during a week? So each day, a day, 75 gallons. So you can write 1 day, 75. Then week means how many days? You get 7 days for a week. So multiply by 7. So what's the answer? 7 times 5, 35. 3 remaining. 7 times 7, 49 plus 3, 52. So 525 gallons. Now it says just to find out the volume. What is the number of times and the total volume of water it can fill during a week? Question number 3. The price of a rambutan is 6 rupees. 5 children bought 2, 3, 4, 5 and 6 rambutans respectively. Find the amount each student spent. 1 rambutan is 6 rupees. And 5 children bought 2, 3, 4, 5 like that. So 2 rambutan multiplied by 2. 12 rupees. 3 rambutan. 6 times 3. 18 rupees. 4 rambutans. 6 times 4. 24 rupees. And 5 rambutan. 6 times 5. 30 rupees. And 6 rambutans. 6 times 6. 36 rupees. So these are the values each child spent. Find the amount each student spent. So this is 6, 12, 18, 24, 30 and 36 rupees. Question number 4. A parcel containing the following items needs to be given to each student who participated in a certain event. Find how much it will cost to give 50 students a parcel each. There are 3 gingerly rolls, talaguli, 1 fish bun, 2 bananas and a packet of milk in each parcel. The price of 1 packet of milk is 30 rupees. The price of gingerly roll is 5 rupees and the price of fish bun is 30 rupees and the price of banana is 10 rupees. So we'll check out for each parcel how much we need to spend. So there are 3 gingerly rolls. So we'll multiply this by 3. So 5 times 3, 15 rupees. Then 1 fish bun. Price of fish bun is 30. So 30 times 1, 30 rupees. Then 2 bananas. 2 bananas means 10 times 2, that's 20 rupees. And a packet of milk in each parcel. So 1 packet is 30. So you get 30 rupees. Now we need to find out the total for all. This is 1 packet. 5. 3 plus 1, 4. 4 plus 3, 7. 7 plus 2, 95 rupees per packet. So how many students are there? 50 students. So we need the cost for 50 students. Total cost is 50 times 95. So what's the total cost? We put a 0 and multiply by 5. 5 times 5, 25, 2 remaining. 5 times 9, 45, plus 2, 47. So we need 4,750 rupees for 50 students. Question number 5. Separate 50 pupils into groups such that each group has an equal number of pupils. What are the numbers which can be taken in each group? That means factors. So into groups. So you can divide by 1. 1 times 50. So that means one group you can make with 50 students. Then it's divisible by 2. 2 times 25. 2 groups with 25 students in each group. And this is divisible by 5. 5 times 10. 5 groups, each 10 students. Then 10 times 5, 25. So those are the possibilities, and other way around is also possible. 10 times 5. 10 groups with 5 students each. And 25 times 2, that means 25 groups with 2 students each. And other way around, 50 times 1, that means 50 groups each with 1 student. So those are the possibilities that we can group. Exercise 11.6. From the following, select and write down the numbers which are divisible by 2. So what's the condition? The last digit should be an even number or 0. So 42, 64, 126, 148, 250. And this number is possible, and here and here. So you have to look at the last digit. What are the digits that the blank box in this number can be filled with if this number consisting of 4 digits is divisible by 2? So last digit should be an even number or 0. So it can be 0, 2, 4, 6, 8. Those are the possibilities. Question number 3. Select and write down the numbers which are suitable for the blank boxes to the right of the box containing numbers. A number could be included in more than one box. Numbers which are divisible by 2. So select even numbers. The last digit is even, 212. Or 0, possible, 310. 256 and 420, 860, 1236 and 5180, 1800, because all are even numbers. Numbers which are divisible by 5. So look at the last digit, either 5 or 0. 105, 310 and 125, 375, 420, 860, 3245, 5180, 1800. Numbers which are divisible by 10, that means last digit should be a 0 value. 310 and 420, 860, 5180 and 1800. Now look at the same question. Are there numbers which are common to all three of the boxes on the right in question 3 above? What are these numbers? So look at carefully. We see all these numbers in this box are here as well. So 310, 420, 860, 5180, 1800. Then second part, are the numbers in box C essentially in boxes A and B? Yes. What are the numbers that are common to both boxes A and B in question 3 above? A and B, what are the numbers common? What are the numbers common? What are the numbers common? 310. Then 420, 860, 5180 and 1800. So that means either the last digit is 0, the last digit is 0 only. So in question 3, examine whether these numbers are in box C as well. Accordingly, write down the conclusion that you can draw. So here we can say what are the numbers that are common to both boxes A and B in question 3 above. So I can write 310, 420, 860, 5180 and 1800. Examine whether these numbers are in box C as well. Accordingly, write down the conclusion that you can draw. When the last digit is 0, it is divisible by 2, 5, 10. Either 2, 5, 10 without a remainder. So that's the conclusion. Then we can say divisible by all three numbers 2, 5, 10. Question number 5. Join the points relevant to the numbers which are divisible by 2 in ascending order. Then join the points relevant to the small number and the largest number you join. So starting from the smallest. Divisible by 2. So that means even numbers. 2, 4. Then what's the next number? 6. 6, 8. Then 10. What's the next number? We can 12, 14, 16, and we can join the largest and the smallest one. So this is a shape of a house. Join the points relevant to the numbers which are divisible by 5 in ascending order, smallest to largest. Then join the points relevant to the smallest number and the largest number you join. So we'll start from 5. Then you get 10. Then you get 15. And then 20. Then 35. 35. After that, 40. 40. Then you get around that 75. Before 75, you get 65. 65, then 75. Then 90, 105. And then you get 110. 110, 120. And then 135. And 100. Then 155. And then you can join the first and the last. So this is a fish. Join the points relevant to the numbers which are divisible by 10 in ascending order. Then join the points relevant to the smallest number and the largest number you join. So multiples of 10. Starting from 10, 10, 20. Then 50. 50 is the next number. And 70. 80. 90. Then 120. And that's the largest, and this is the smallest we can join. So this is a boat. Now we'll look at the miscellaneous exercise. Give reasons why 7 is not a factor of 45. We can divide and see. When you divide by 7, you get 7 times 6, 42. And the remainder is 3. So we can say 7 is not a factor as the remainder is 3. Question number 2. All the factors of a certain number apart from the number itself are 1, 2, 3, 4 and 6. What is this number? So what can you say? If you take 12 is divisible by 2. You get 6. 12 is divisible by 3. You get 4. 12 is divisible by 6. That's 2. 6 times 2, 3 times 4. Apart from the number itself, that means 1 and 12. So, what is this number? You get 12. The number of marbles in a certain box is a multiple of 6. When this number is rounded off to the nearest multiple of 10, the value obtained is 40. Write down the two values that the number of marbles in the box can take. So, rounded to the nearest multiple of 10. So, you can, when you round it to the nearest 10, it can be above this can we take 40 something? You can't take 46 above 46 or 45 you can't take. So, what are the numbers you can take? You can take 41, 42, 43, 44, up to 44. And below, what are the numbers you can get when you round it to nearest 10? You need to get 40. 39 is okay. 38, 37, 36 and 35. You can't take 34, then that number becomes 30 when you round it to the nearest 10. Now, this is a multiple of 6. So, what are the multiples of 6? Either 36 or 42. So, write down the two values that the number of marbles in the box can take, 36 or 42. Question number 4. The number of biscuits there are in a certain packet of biscuits is a multiple of 4, which is less than 20. When this number is rounded off to the nearest multiple of 10, the value obtained is 20. How many biscuits are there in the packet? So, this number is less than 20. So, what are the possibilities? You can get 19, 18, 17, 16 and 15. But you can't take 14 because when you round 14 to the nearest 10, it becomes 10. So, these are the possibilities. And this number is a multiple of 4. Only you get 16. You can't take 20 because that's less than 20. So, how many biscuits are there in the packet? It's 16. Now, we covered all theory related to factors and multiples. A whole number is divisible by each of its factors. When a whole number is multiplied by another whole number, multiple of the initial number is obtained. If the value of the digit in the ones place of a number is divisible by 2, then the number is divisible by 2. That means the last digit. The digit in the ones place of a number which is divisible by 5 is either 0 or 5. The digit in the ones place of a number which is divisible by 10 is 0. So, remember all these to identify whether any number is divisible by 2, 5 and 10.